Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today is obviously not just another live stream. We're doing something a little different today. Today, I have three guests. I'll introduce them to you shortly. But today's topic is one we think you'll really be interested in. It is discussing AI at Horner Automation. Now, artificial intelligence, machine learning, deep learning, those are three terms that you hear a lot these days, and they're not really just buzzwords. They, to a large extent, represent the future of automation. So today, we thought we would spend some time, give you a little bit of education on AI and automation, and also let you know what Horner is up to in that area these days. So I've got three special guests. Let me introduce them to you now. Now, one of them ought to be very familiar. Casey Gardner, our product manager. Thanks for joining us.
Of course.
Now, you know, Casey, it's been a few months since I've had you on.
It really has.
We really need to make that more regular.
Absolutely.
All right, we're going to work on that. Now, the other two faces are new. Let's start with the gentleman immediately on my right here, and that is Don Clutterbuck. How we doing, Don?
Fantastic.
Awesome. And then we have Phillip Archuleta also joining us today.
Yeah, how's it going?
It's going terrific. Okay, so let's take a look at how we're breaking down the topic today, and then we'll have kind of individual conversations with each of these fine gentlemen. So our agenda today will start with, what is artificial intelligence? We want to go over some of the terms and really what do they mean? Also, how is AI currently being applied in industrial automation? That's something that we'll explore. What are the requirements to implement AI? If you have interest in implementing artificial intelligence in the future in your application, you need to know what the requirements are. And then we're going to talk quite a bit about what is Horner actually working on in this area and what is the vision for AI at Horner. So hopefully you'll get a lot out of this topic. So our first guest today for today's topic is Phillip Archuleta. Now, Phillip is the product manager for AI here at Horner. Phillip, thanks for joining us today.
Yeah, thank you for having me.
Very good. Why don't you tell us a little bit about yourself and your background?
Yeah, sure. So I am the AI product manager, as Chuck explained. I've been here in this position for about 6-8 months now. Before that, I was a student at Purdue. I have 2 degrees from Purdue, both in computer engineering, bachelor's and master's. Specialize in AI for my master's. So what I do here is very much in that field, very concentrated, a lot of research. So yeah, it's pretty good overview.
Terrific. Now, kind of a fun fact. I actually did my senior thesis in 1989 on artificial intelligence. How about that for timely, huh? But I will tell you, you're way more qualified to speak of artificial intelligence than I am. 1989 was a long time ago. It was quite a while ago. Okay, so we're going to start our discussion with you, Phillip, on definitions for artificial intelligence. Why don't you help us along with some of the key terms when it comes to AI?
Sure. So everyone's heard of AI, right? It's kind of a general blanket term. There isn't really a good definition for AI. It's kind of whatever you want it to mean. So Google says that it's machines with human-like capabilities. So if you look on the right side of the screen here, you see this overarching circle. Everything that's comprised within AI is AI. AI is the biggest category, right? After that, you have machine learning. This is defined both academically and scientifically as algorithms that learn from data. So this is a subset of AI. Not all AI is ML, and likewise, all ML is AI. Then you have deep learning. This is a very specific subset of AI and machine learning. This makes use of neural networks, which are very popular, very common term. And then this is a subset of machine learning. So this goes further in the diagram. And then you have LLMs. So this is like ChatGPT. These are your large language models. So this is an application of deep learning, primarily neural networks, on languages such as English. So that's where ChatGPT comes from. And then this is within deep learning. And then likewise, you have computer vision, also within deep learning. This is any kind of neural network work that you're doing with images or videos or something like that.
So obviously, if you want to know what was going on in AI in 1989, I'm the guy to ask. But if you want to know what's going on in the industry today in AI, I'm not the guy to ask. So Phillip, why don't you fill us in on what is going on in the industry these days with AI.
So right now, the biggest thing is everyone is pushing for a mass data collection. Everyone wants their customers to collect data, because without data, you can't do AI. So the biggest thing right now is just data, data, data. Everyone wants it, everyone needs it, and everyone, to be truthful, to get a good AI model going, you need a lot of it. You need months, years possibly in some cases. So everyone's trying to get their stakes in now in the data, hoping it pays off. Then we have large language models such as ChatGPT being used for like ladder logic development, such as what we do in Seascape. So that is something that the industry is doing. They're particularly using ChatGPT models from OpenAI in order to do this, try to speed up development. Then you have free, right? The simulation of plant scenarios. So this is some machine in a factory or a whole line or something like that for data augmentation purposes. So what that means is data augmentation is generally the production of synthetic data to train an existing network. You're supplementing the data you have or may not have. Right?
So it's kind of a simulation, if you will.
Yeah.
Okay.
So you're simulating this plant scenario to come up with realistic data.
Okay.
So you're simulating a machine or a conveyor belt or something, try to get a metric that you could then say, okay, this isn't real, but it's close enough. We can use this for real data to train our AI models.
Got it.
So those are the first three. Then you have anomaly detection and sensor value estimation. So anomaly detection is like if you have like a motor or something running, something that's giving you an amount of current you can read. You're looking for spikes. You're looking for outlier cases. These would be anomalies that could be detected by a deep learning model, such as a neural network. And then sensor value estimation, similar. Let's say you have 5 sensors in the room. You know what 4 of them are. They're all the same kind of sensor. You can kind of assume what that 5th one is based on the 4. That's what that is.
Okay.
Customer requested solutions are really popular right now. So essentially, customer requested solutions are, I come to you and you have a company and you want a model that does very specific X, Y, and Z. So we make a model for you that does X, Y, and Z.
So if you are a manufacturer that makes products or makes machines in a certain industry, you have a certain application that you would like to have AI applied into. So you would contact an automation manufacturer to try and work with them to develop that sort of area.
Yeah, absolutely. And typically these tend to be more complex. So simpler things can typically just, off-the-shelf models. But as you get to these more complex and involved systems, you do sometimes need a specialist. And that's where this will come in number 5.
Okay.
Then we have number 6. So this is development of neural processing units, an MPU, compatible with existing PLCs. So we're essentially talking about a box that hooks up to a PLC that has either an MPU, which is a CPU or a GPU specialized for neural networks, or a GPU outright. And essentially, with these boxes, you can then bring models that you have already trained and run them directly with PLCs.
So it's kind of like a coprocessor, if you will.
Yes,
kind of, sort of.
yes, yeah,
Okay,
very
got
similar,
it. But an AI coprocessor for all
Yeah.
intents and purposes.
Yeah.
All right.
And then the last thing on my list here is large language models for customer interaction. So this would be a tech support assistant or a sales assistant or something along those lines, a little bit just to automate kind of the ongoing customer relations part of the business.
Okay, so when you're on a website and it's after hours and you're interfacing with a chatbot or something like that, that's what we're talking about here.
Yeah.
Okay. Wow, there's a lot going on with that.
Yeah, there certainly is.
Now, all of that sounds good, but there's obviously limitations right now in what's going on with the industry. Why don't you go through some of those as well?
So if anyone's ever used ChatGPT extensively, you know that there's times where it doesn't work very well. It's the same exact model they're using for this ladder logic development in industry. So it already doesn't work great, and then you're asking it to do something kind of complex. Typically your results are not the best. As of now, a couple years from now, the story very well could be different. But as of now, the LLMs, you can get some ladder logic, you're still going to have someone look at it.
Right. Right. You're going to have to know what you're looking at. You're going to have to know how to test it.
Yeah.
You're going to have to prove it all out. And I mean, the same thing applies. I mean, I'm sure other languages are easier than ladder, but structured text, I know you certainly, ChatGPT can spit out structured text for sure. But again, somebody's got to be able to validate that what you asked for is actually what you got and that it actually works.
And in some circumstances, it might just be easier to just do it manually.
Sure.
Rather than having to make it and proofread it and test it.
Right. I mean, we all had to learn how to use search engines, right? I mean, we know if we don't search for the right thing, we don't get the results we want. So this is just a really, really high, I mean, I'm being very overly simplistic, but it's a very high-tech search engine, really.
No, I mean, that's a pretty good description, I
Okay.
would say, for this purpose. And then moving on from that, the anomaly detection and sensor value functionalities that I previously mentioned, so detecting an outlier in a group of data, like a real-time group of data, or extrapolating sensor value based on other sensors near it, you don't really need AI for that. I mean, this technology has existed for years and years and years. I mean, you can do this with some logic, some if statements, you can kind of pull something like this off. And then one of our competitors, MPUs, the neural processing unit, this is kind of the co-processor, right, for AI. You have to bring your own trained models. It's not like they're giving you models, they're generic ones. And it doesn't support one of the most popular frameworks, which is PyTorch, which is also known as Caffe2. It supports Caffe1, supports TensorFlow, which are both popular ones, but it's a pretty big critical missing component to not have.
Yeah, and that's one of the challenges of being first, right? Being first doesn't always mean that you're going to have really a practical solution that has what people really need, right?
Yeah, absolutely.
So that can be a real challenge. So in the next part of our discussion with Phillip, we're going to talk about some actual projects that are underway at Horner. So why don't we get started with the first one?
Yeah, so this is our PID coefficient auto-tuning using AI. So to kind of give a brief technical overview, here we have a PID equation with your U of T being your control output. So this is something you would feed to a motor or a heater or something else that's being controlled by PID. Your E of T is your error term. So this is your difference between your desired value and your current value of a process variable, such as temperature in a tank or something like that. And then your KP, KI, and KD are the PID coefficients. So anyone who's used a PID loop knows that you have to get these coefficients right. It's critically important, or else your PID loop is not going to work. Currently, we offer some solutions for our customers to be able to auto-train or auto-tune, but they're limited. So one of them is a manual tuning, which is, here's the equation, go for it, kind of deal.
Yeah, really, that's kind of, it's really a matter of, you use your own knowledge of the application of the process and how you know that it reacts, and you use educated guesses as to how much of each of the three different coefficients you're going to need. You usually start with, obviously you start with P and you work your way through it, but it's again a lot of it's not really auto tuning at that stage. It's manual, and you are you're doing experiments and seeing what the results are.
Exactly, yeah. And this requires a subject matter expert, which some companies might not have, or some companies might want to use their subject matter experts differently, right?
Sure.
In terms of just resourcing.
Right.
I know we have Ziegler-Nichols open loop tuning, just straight up. We do offer this through Seascape, but it's rather, I won't call it limited, but it's rather old. They invented this algorithm in the 1940s.
Absolutely.
Right after World War II.
No question. Even earlier than the 1980s, I might add. Yeah, it had been
earlier.
40 years old by the time that I was doing PID.
Exactly. So it works. It's been the industry standard for a long time. But I would say it's relatively quick in most applications. The problem becomes that it's only decently accurate at best. Sometimes you'll do an open loop tuning and you'll get real consistent results and everything is fine. And then sometimes you'll do it and it'll work for half an hour, then it won't. So there's a kind of a mix. And then sometimes it does mostly work, but it'll stray too far from your desired value, just kind of regularly.
So I think for the folks that use auto tuning, Ziegler-Nichols based auto tuning, I think if they have appropriate expectations, they know that it can probably get them in the ballpark. It might get them almost all the way there, but it certainly should get them in the ballpark if it works. But what you're talking about with AI enhanced Ziegler-Nichols, hopefully that'll work a lot better in getting all the way there, or at least very
100%.
close.
Yes, absolutely. And then this very current option is what you just described essentially. You get close with the Ziegler-Nichols, and then you have to manually finish it off.
Okay.
That's currently kind of the best approach.
Right.
Generally, it seems.
Sure.
Yeah.
Okay, but how are we going to apply AI with this tuning method?
Yeah, absolutely. So this is what Ziegler-Nichols looks like, right? Just kind of a standard. You're looking for these three different values: your lag time, your overall change, and then the overall change in the control value.
Right.
Apply some algebra to this, you get your coefficients.
Right. That gives you your first cut at your coefficients.
Yeah.
Exactly.
Now we can start with something like this, get our first cut at our coefficients, and then use that guess with machine learning technologies to then refine the guess even further.
That sounds promising.
So we investigated a few different algorithms. Two of them were just kind of, for lack of a better term, dumb machine learning approaches, and then one was a deep learning approach. So when I say dumb machine learning, I'm kind of referring to the fact that you don't have to have data going into it, whereas with a deep learning approach you do, right?
Okay.
So the two machine learning approaches were genetic algorithms and particle swarm optimization. These are essentially refined guessers. You start with a set of values, and then you kind of guess a little bit, and you figure out what the quality of these guesses are, and you just keep refining until you get good enough.
Okay, so it's kind of another weirdo analogy, I suppose. It's kind of like playing 20 questions, right? You're kind of getting closer and closer as you go.
Absolutely.
Okay, got it.
And that's kind of how both of them work. They're very similar. There are some differences, but they're very similar in how they work. Then we have reinforcement learning, which we investigated but did not implement. This is a deep learning technology. So this is very data heavy. It provided good results, but it has an excessive training time. We're probably talking 100, 200 times what people are used to with learning. So it's too long to be effective here, but it's still something that we looked into.
So really what you're looking at here is we've tried a couple different variations of machine learning, which doesn't require tons of data, that we could potentially implement much faster than a model where we need 6 months, a year, 2-3 years worth of data, which should allow us, in theory, right? It should allow us to develop an algorithm, a AI-assisted auto-tune, much quicker than otherwise, right?
Yeah, absolutely.
Okay, sounds good. So just to summarize, what we're really looking at here is a AI-assisted Ziegler-Nichols tuning, where we use Ziegler-Nichols to get in the ballpark, and then that provides the guidelines that are needed for these machine learning algorithms to be effective.
Absolutely, yeah, exactly like that. Yeah.
Terrific. Okay, the next project we're going to talk about, I'm not so sure how I feel about it, but it should be pretty exciting. And that is we're developing an AI ChatBot for customer support to kind of augment our tech support guys. Now, this is not to replace our tech support guys. This is just to provide an additional tool for customers to use to get help, either when someone isn't available, after hours, whatever the case might be. So why don't you tell us about kind of the technology behind what we're doing here and what some of the goals are for the project?
Sure. So we're applying OpenAI ChatGPT within the realm of our products, kind of trained a little bit more extensively on our specific documentation. And we're doing this to kind of improve the customer service experience overall, right? That's kind of the technical goal of it. Then there's a business goal, which, as Chuck had mentioned, you want to, provide another tool for customers to be able to get support from, maybe off the standard business hours or something like that. So that's kind of where those come from. It's a deep learning model, right? So it's a large language model based on OpenAI's ChatGPT.
Right.
And it currently is in development. We have very good results already. We're just kind of waiting for a future release of GPT to get even better before we push it out to our customers.
Okay, so we're probably looking at the second half of 2024 as to when we would roll that out. Okay, so I believe on the next slide we have kind of some screenshots or representations of what we have so far. So the part I'm not so sure about is what that dude looks like. That is the chatbot at Horner. So I'm not quite so sure about that. But anyway, those are just some screenshots as examples of kind of what those chats could look like, right?
Yeah. So here we have ChuckBot, right? So you go into
that's kind of the internal name for it. It's the ChuckBot. Boy. Anyway, go ahead. I'm sorry to interrupt you there.
No, you're fine. You go into your chat, right? So on the left here, you see what it would look like when you open it up. So from the beginning, you don't have to interact with this, right? From the beginning, you have the opportunity to email and call live support directly.
Of course, yes.
We're not trying to force people to use a chatbot.
Again, it's another tool.
Another tool.
Absolutely.
Exactly. So you started off, you tell it good morning. ChuckBot, said good morning. How can I assist you today? And in this example, we gave it a very basic issue to kind of show the versatility of it. So we're having issues connecting the PLC to the network. Okay, so ChuckBot asks for more detail. We give a little bit more detail. We say our OCS X7 says there's no connection. Then we get a very detailed, 5-step response here. That's factually accurate. I mean, that is what you would want to do kind of with this limited information.
Absolutely.
So you get a very detailed response. At the end, there's a follow-up number.
Right.
And it ends the chat on its own. So a customer won't get stuck talking this all day.
Sure.
It'll end the chat. And if at the end of this you're still not satisfied, you have the opportunity to submit a ticket right there. You can go back and call live support. There's options.
Okay, very good. Now, the particular AI project I had that was part of my thesis wasn't exactly a chatbot. Obviously, the technology was a lot different back then. But it was basically helping a maintenance person troubleshoot a specific type of machine failure, was what that was.
Okay.
So it was really a matter of me interviewing the experts at the company and how to make this type of repair and making sure I got the key salient information in the system so that it would come out, when the appropriate questions were asked. So, that was 1989's version. I think 2024's version is a little more advanced than that. Just a little bit. All right, very good. Okay, now earlier when we were talking about different AI algorithms, you mentioned that the ones that are the most effective are the ones that require a ton of data, maybe 6 months, 12 months, 24 months, or even more data. So what is the key for those sort of algorithms to be able to work?
The key is start collecting your data now. I mean, that's the key. It's you might not have an AI application today, and you might not have a model you want to use today, but 5-10 years from now, you probably will. And if you have that data existing on hard drives in a future, on an OCS 360 application, which we'll address in a little bit, if you have your data stored and something like that, it will be useful when you want to use AI. You might not see it coming now, but it's coming. You will want to use it at some point, and you need to have that data to use this subset of the most powerful tools.
Yeah, because if your manager comes to you 6 months from now or 2 years from now even and says, hey, our competitor is using AI, what are we going to do? How are we going to match that? If you haven't already started the process of gathering your data and you don't have that data there ready to go, there's not a lot you can do until you do have that data. So that's a nice segue. Our next conversation will be really talking about what Horner is doing and planning to help our customers collect that sort of data. So Phillip, I want to thank you for joining me today and really interesting information.
Yeah, of course, anytime.
Okay, so for my next guest, I have an old friend of mine actually, who is a new employee at Horner.
Yes.
Don Clutterbuck. Thanks for joining us, Don.
Thank you.
All right. Well,
Very old friend.
Absolutely. So we've been working together for 30 years?
30 years. Yeah.
But not working at the same company. So
Correct. For 30 years, I worked at a distributor, which is a very large Horner customer.
Absolutely.
And I cut my teeth on all the old Horner OCSs and moved into management and decided I had enough of that. And Phil and I talked, and
all right.
I came a month ago.
Yeah, excellent. So you wanted to get back into the tech stuff like I did. I kind of had a similar path. I never made it up into management that high necessarily, which isn't a bad thing, believe me. But the last few years, I've really been diving into the tech a lot more than I had maybe the previous few years.
Yes.
So, and that is something that when you're tech geeks like the two of us are, that is enjoyable. Okay, so let's talk about what you're up to these days at Horner. So during my conversations with Phillip, we talked about the fact that AI applications are really data hungry, and he mentioned something called OCS 360 that was a potential tool for customers to use to start gathering that AI data. So why don't you tell us what you're up to in regards to OCS 360 and what OCS 360 is?
Okay, Phillip was correct. OCS 360 is the Horner platform for visualization, cloud-based visualization, data collection, and remote connection.
Okay.
You can collect data, SD card, we talked about that for years,
Right.
but there will be a web base that you can do predictive maintenance, alarming, SMS messaging, remote connectivity, like I said.
Right.
So it's a web-based platform.
All right, and if I remember correctly, there's also plans on kind of remote access being part of that as well, right? So if you're a machine builder and you want to have access from a maintenance or troubleshooting standpoint, that'll also be one of the things that's included.
OCS 360 will be your connection point. Dedicated VPN, that sort of thing. Yes.
Okay, so it sounds like there are a lot of elements to OCS 360, but what would you say the main focus is?
The main focus is to help our customers collect that data that they're going to need if and when they implement an AI solution. Whether it's government regulations coming down the pike, traceability, part tracking,
Mhm.
you're going to need that data to start doing all of that. And that's the main vehicle for OCS 360.
Terrific.
Yep.
So I believe the first trade show that we're going to be showing, or at least an early preview of OCS 360, will probably be, we've got a distributor event in April, but I think the first big public event is going to be the Automate trade show in Chicago that both of us are going to be attending, right?
Correct. Yes.
Awesome. All right, we're going to be roomies, so that should be interesting. We were roomies in Las Vegas years ago, weren't we? At the Consumer Electronics
Long
Show.
time.
That was a long
Electronics
time
Show.
ago.
Absolutely.
All right, very good. Well, Don, it's been a pleasure.
Thank you.
Thanks for joining me.
Okay.
Okay, so our third and final guest today is a familiar face to those of you who watch the Horner YouTube channel on a regular basis. It's our product manager, Casey Gardner. How are we doing, Casey?
I'm good. How's it going, Chuck?
It's going great. Now, I have to admit, it's been a while since we've had you on the channel, but I know you've got a lot going on at home and you've got a lot going on as our product manager.
Yeah, I'm definitely guilty in that regard. So I've got 2 kids under 3, so that's a lot going on at home for sure. But in the Horner world, we've got a whole lot that we're excited for 2024. But that also means letting you handle some of these YouTube streams as well. So.
Absolutely, and I'm managing without you, but it's always fun when you can join me. So today's topic, of course, is all about AI. So, and you're our primary product manager for our standard product lines. I mean, you're steering the vision of the company on our traditional products. So what is your vision on how AI will kind of integrate with our standard automation products?
Sure. So kind of touching on what Don and Phillip had also mentioned is we've got a number of different AI research and projects that will really incorporate with a lot of those different standard products. So things like AI PID tuning or AI HVAC tuning type projects where we're either gathering that data or doing a lot of our own modeling to see what we can do to help incorporate or increase the deployment time for a lot of those type of applications, and also things like actually building in or involving a neural processing unit to be able to do a lot of the AI modeling on the OCS hardware itself, as opposed to needing some sort of co-processor model like what Phillip had discussed for traditional AI tuning for that matter. So again, that's something we're pretty excited for down the road as well.
Yeah, so I mean that is very interesting. I know that we've actually got some development going on. It's still a long ways away, like you said, in developing hardware that's AI capable.
Yeah, absolutely. And again, it's stuff we're always keeping an ear to the floor on where that market's going. But again, it's a lot of exciting capabilities that we want to be involved in for sure.
All right. Now, another kind of hot topic in AI is, of course, ChatGPT, right? And Phillip covered some of that earlier. And one of the things he talked about was, you know, you're seeing more code development type tools using ChatGPT as a goal of code development. In general, what is your thought kind of on using a tool like ChatGPT, for instance, for code development, like within Cscape or something like that?
Sure. So, I mean, the output is only going to be as good as the data you give it, right? So there's still quite a lot of implementation of feeding it that kind of data over time before it's to a point where it's any good for that matter or useful.
Right.
And really at the end of the day, there's going to be a lot of scenarios where, again, depending on the customizations needed for an application, you may still need somebody as knowledgeable for the application that would have written it in the first place. Now, again, it may, the goal is still to help speed up that development time for the most part, right? So again, if we can take a lot of that effort out of the main project for that matter,
Sure.
Really that just gets all of our visions implemented faster.
Right. I mean, it's another tool, right? I mean, it's like I mentioned earlier, we all got used to using browsers, and not just browsers, but search engines to help us be more efficient. Yeah. This is ultimately probably 3 to 5 years from now, we'll think of it as just another search engine, another tool like that at least.
Yeah, absolutely. And instead of having to, again, trust a random source on the internet as far as some source code that you want to borrow, well, again, you may get to a point where a model is trustworthy enough that they can generate a very quick part of your application for you. So that's what we're looking forward to.
Okay, so as we kind of close out our discussion on AI today, any other thoughts?
For the most part, again, for our implementation, some of the main focuses is going to be using it for practical applications. So again, we talked about the modeling needed. Well, that means there's got to be a lot more repetition and a lot more data into that field. So it's going to be something, as far as practicality, has got to be a big focus. And from a Horner perspective, it also has to be easy to use.
Right.
So again, the simplicity of communications, the simplicity of implementing these kind of tools and features have to be easy to use and not require, again, an expert in the field. Otherwise, you're kind of running a point.
Exactly, right. And when he says expert in the field, we still need the experts in automation in the field. I think he's talking about the experts in AI, right? You
Yes.
don't want to necessarily have to have your own AI PhD just to start working with it.
Yes, absolutely.
All right, very good. Well, thanks again, Casey, for joining us. It's been an interesting discussion today.
Yeah, thanks for having me.
Okay, so gentlemen, that's our conversation for today. I really enjoyed it. Thanks for joining me. Hopefully, our customers and our future customers got a lot out of that discussion. So this is the point in the program where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live or pre-recorded like today, but we always have somebody standing by to answer your questions in the chat section if you're watching live, or in the comment section if you're watching on replay. Now, I want to remind you that if you're interested in some of the things we've talked about today and some of the new products we have coming in 2024, I've got the 2024 trade show here on the screen. So make plans now to come to one of these trade shows and see firsthand what Horner is working on. Okay. So there are lots of ways to interact with us online. You can interact with us on our website, of course, on our YouTube channel. If you're active in LinkedIn, we definitely are. So we look forward to making a connection in one of these ways online. Okay, in terms of our live streams coming up for March, you will see on our website the complete March schedule, but we do know what we're doing for the next 2 weeks. So for the next 2 weeks, we're going to be talking about implementing a custom UI, a custom user interface on the Horner OCS. So if you are working with your marketing group or with a graphic designer within your company, or maybe your company hired someone to design a user interface for your machine, we're going to show you how you can take that user interface and apply it in the Horner OCS. So don't hesitate to join us. We think that's going to be a great topic. And we're going to cover it over a 2-week period. So until next week, let's all get out there and do some good.